Hello and welcome to another episode of Twiml Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. Once again, thanks so much to everyone who sent in their favorite quote from last week's podcast. Your stickers are on the way. We've had a blast receiving and reviewing all of your quotes. Don't forget to send us your favorite quote from today's show as well, because this contest will continue while our sticker supply lasts. You can do that via a comment on the show notes page or a comment or post on our Facebook, Twitter, YouTube, or SoundCloud pages. If you've been listening to the podcast for a while, you know that I really enjoy hearing from listeners, and I appreciate all of the comments and feedback I get from all of you. Now, I haven't mentioned this in a while, but one of the most important ways you can provide feedback is through an iTunes review. According to our stats, the vast majority of our listeners come from iOS and iTunes, and many of them, one can only suppose, find the podcast via the iTunes directory. That's why your reviews there are so important. The more and better they are, the more people will want to check out the podcast. So please take a moment to review the show on iTunes. We'll have our link to the iTunes page in the show notes, so you can click right through from there. And you don't need to be a regular iTunes user to leave a review. Of course, if iTunes just isn't your thing and you've got other ways you prefer to spread the word about the podcast, those are appreciated as well. Thanks so much for spreading the word. The interview you'll hear on today's show was recorded last fall at the O'Reilly AI conference in New York City. On the subject of that conference, it's returning to New York in June. And this time around, we'll be giving away passes to 2 lucky Twiml listeners. Stay tuned because that giveaway is coming soon. If you happen to be in New York City now, I want to call your attention to another event that'll be taking place, this one next week. That event is called the Future Labs AI Summit, and it'll be held at NYU on Wednesday afternoon. Speakers at the event will include Facebook and NYU's Jan LeCun and NYU's Gary Marcus. I'll drop a link to this one in the show notes. Check it out if you're in the city. It sounds like a great event. Finally, I'd like to take a minute to remind you to check out my upcoming event, the Future of Data Summit, which will be held May 15th and 16th in Las Vegas, Nevada. If you haven't already checked out the event, I really encourage you to take a look. The person I had in mind when I created this event is someone who's in a role where they're responsible for helping to chart an organization's data strategy, or someone who wants to be in that kind of role, or someone who needs to understand how all of this will come together. This isn't the place where we'll go deep on neural nets, pun intended, or the latest research paper. Rather, this is an interdisciplinary summit where you'll get to hear from and engage with experts presenting on various aspects of our data-centric future. You'll hear from Asaf Araki, an expert in big data infrastructure at Intel, on the coming advances in hardware and what they'll allow us to do in machine learning, AI, analytics, and more. You'll hear about how cloud, IoT, and big data shift the cybersecurity threat landscape, and how we can secure these systems, from IBM's Global Executive Security Advisor, Diana Kelly. I'll be leading a discussion on data privacy and algorithmic ethics with Accenture AI's Ruman Chaudhry and Ericsson's Jonathan King. Eric Sammer, founder and CTO of Rokana, will talk about the role of AI in optimizing the enterprise data center, so-called AIOps. And Endeavor VR founder Amy Peck will talk about the emerging role of virtual and augmented reality in the enterprise. These are just a few of the speakers I've lined up for you, and I'll be announcing more shortly. To learn more about the summit, visit twimlai.com/futureofdata. Now, about today's show. This week, my guest is Alekh Agarwal. Alekh is a researcher with Microsoft Research in New York City, where his work is focused on interactive machine learning. As I mentioned before, Alekh and I recorded this show at the O'Reilly AI conference, where he delivered a talk called Interactive Learning Systems, Why Now and How. Interactive learning systems are different from traditional supervised machine learning systems in that they need to explore and learn from their environments. This is an exciting area of research and one that really interests me personally. in part because it incorporates concepts like active learning, reinforcement learning, contextual bandits, and much more. If you're interested in this topic, when you're done with this show, you should listen to the show I did with Georgia Tech's Charles Isbell if you haven't already. That was show number 4. The notes for this show can be found at twimlai.com/talk/17. And now, on to the show. Hey everyone, I'm here with Alekh Agarwal with Microsoft Research, and we're here at day 2 of the O'Reilly AI conference. Alekh just did a great presentation on interactive learning systems, and he was kind enough to join us to talk a little bit about that presentation. Alekh, why don't you start off by introducing yourself?
Yeah, sure. So I'm Alekh Agarwal. I'm a researcher at Microsoft Research, actually here in New York City. I've been here for 4 years. Prior to that, I was doing my PhD at UC Berkeley. And my work really touches upon a lot of themes in AI, but one that has particularly, and in machine learning, but one that has particularly been of interest lately is what I call interactive machine learning. So thinking about problems where the machine learning algorithm is not just learning from a static pool of data that was hand annotated and collected by somebody else, but thinking about really how the algorithm has to interact within a larger system, within a larger environment to collect that data, to gather learning cues, and then incorporate learning cues into the model in order to improve over time. And this leads to several kind of paradigms in machine learning, things like active learning, reinforcement learning, or subsets of reinforcement learning like contextual bandits and so on, all of which I worked on and were touched upon in the talk today.
Great. So you mentioned the machine learning, learning from the environment, and one of the ways you illustrated that in your talk was you showed a demonstration of a Super Mario Brothers game. Can you talk about what you were intending to show with that demo? And
So in some sense, whenever we are thinking about interactive learning systems, right? So one of the question is, what are environments in which we can safely run these experiments, in which we can have this, are basically algorithmic agents interact with their environment or manipulate the environment in a safe manner. Of course, the natural or maybe canonical embodiment even in everybody's thinking of such agents are robots, right? But robots are hard to program. It's hard to, in fact, control all of their sensors and actuators, and it takes time. It takes resources even to get one. And so a lot of people have found designing agents for various sort of games, either computer games or even traditional board games, right, like backgammon, chess, Go now, and other such games as kind of more controlled environments in which we can still have this interaction either with another player or with its with the environment of the game. And we can run these experiments kind of over and over again with actually remarkably high throughput. We can overclock these games, so it allows for very fast experimentation.
Right.
And so that's kind of the reason why people have really gravitated towards using games. In particular, now there is this Atari learning environment, which is basically using Atari games again as a platform to test interactive learning situations. And what I was trying to show in the particular Super Mario demo, actually, so I should give credit to Stefan Ross, whose work that video comes out of. So what they were trying to demonstrate was supervised learning is not adequate, or a static pool of data is not adequate to do well in interactive learning problems, because when you manipulate your environment, then if you act a certain way, you see situations that may or may not be present in your training data. So, if I know how to drive well, then I might not get into a car accident, or at least not an obvious one, or I might not get stuck behind a slow driving car very often. And now, of course, you don't, if you don't see any data for how to recover from those errors, then, your driving agent is in trouble. So that's the part I was trying to emphasize, that when we try to do supervised learning in these interactive scenarios, then often our algorithms tend to make mistakes that we don't have in the training data, and then they don't know how to recover from those. Mm-hmm. And so they get, stuck in corners, and they just fall maybe in pits and do all sorts of silly things that we just don't do.
Right. So walk us through how the approaches to interactive learning that you talked about address that problem.
Yeah. So in some sense, here's an alternative we could think about, right? So let's say I was thinking about a conversational agent, like a chatbot. So I have two options. I could look through many transcripts of, how people have talked to each other, maybe in a controlled domain, even like a call center or something. And I can try to train an agent from this data. Again, this might have issues that maybe I said something that doesn't make sense to the user. Maybe they respond in a way that a call center human agent would never encounter, and I don't know how to respond now. Now, imagine in this situation, instead of just being stuck and floundering, I could actually sort of fall back to a human agent and say, hey, I'm kind of uncertain about what to do right now. Can you bail me out, please? Right now, I have learned how to recover from this mistake. So in future, even if I'm about to make this mistake, I'll be able to recover from it, right? And so there is this concept of learning in situations that I encounter that interactive learning algorithms usually embody, right? And another kind of thing that often comes up is just even, these are like very ambitious tasks, of course, right? So let's think about something even which seems much more mundane to us. Ranking search results or recommending news articles, personalizing news articles. So maybe I have data of what users have been clicking on, and I learn from this data, and I think I have found something better to choose, right? How do I evaluate it? Well, if these other set of choices are never displayed to the users by my previous system, I have no data that can actually back that these choices are good. Right. And so
we only know the performance of the thing that the user actually clicked on. We don't have any information about how the other things would have performed.
Exactly. And so we run into this problem that we don't even know how to evaluate a system that does something different from what we have in the data. And basically, interactive learning exactly tries to bridge this gap. It tries to come up with techniques for essentially you have to kind of learn on the job. You have to learn on the fly in order to address these situations.
Now, it seems like you've talked about two different things. One is, you've got your machine prediction. How do we kind of pop out of that loop and get input from the human? And the other makes me think more of like multivariate testing, A/B testing, that kind of explore, exploit kind of scenarios. How are those related?
So in some sense, explore, exploit is kind of one step further from this, like evaluation problem that I'm mentioning. So if you think about exploration, why do you explore, right? You explore because, sometimes you'll try one thing, sometimes you'll try another thing. So let's kind of, in a statistical sense, if we zoom out and think about what's happening in expectation, roughly, you're trying everything. And in expectation, at least sort of as a population level, you're getting feedback about everything, right? And what, as a result, that enables you to do is it enables you to evaluate every choice that you could have made, right? So implicit in explore, exploit is this ability to evaluate in interactive settings. And so what I try to do is explore, exploit kind of in my mind consists of two parts. There is this ability to evaluate, which I think is very crucial in its own, because people currently do often evaluation by doing, like you're saying, A/B testing or multivariate testing, which is a horribly inefficient way of going about the task. And explore, exploit basically gives you a much more data efficient way of doing the same thing. And then it lets you, in fact, do something much more. It lets you actually refine your models in real time and update them and, do this sort of really online learning, which is great. But even if you don't want to do that, just this evaluation is something you can already get a lot of value out of. So that's why I kind of try to present both the pieces in their own right. But in some sense, yes, explore, exploit is the general sort of overarching solution that addresses basically both of the issues.
And why does it end up being so much more data efficient than the traditional approaches?
Right. So there are two important hallmarks. So let's first start from a non-contextual setting, right? So let's just say you're trying to basically find the most popular news story that works for everyone. Mm-hmm. Then the A/B testing way, so to say, of going about it would be, let's say you have 10, you give 1/10 of traffic to each one of them. Week later, you see which one did the best. Okay. The explore exploit way of doing is you say, okay, well, initially, yeah, I'll start giving 10% traffic to each one. The moment something starts to look better than the others, I can dynamically adjust my traffic, right? So everything is getting only enough traffic that I need to rule it out as being inferior, right? And so that's already data efficient. However, now let's think about personalization, about contextualization, right? You said you're from St. Louis. You're hopefully not the only user from St. Louis who visits MSN. So you visit, I maybe give you a randomized choice of news story, and maybe another user who has more or less the same features as you visits, right? I maybe try a different news story for them. Now, what I've done is, actually, let's back up. So usually for personalization, let's again contrast with an A/B test. So an A/B test would say, okay, so I'll run this experiment on some percent of data to evaluate B, on some percent of data to evaluate A. Right. So each data point is either going to A or to B. Right. There is no sort of data sharing happening. Mm-hmm. However, when you have a large class of available options, available models that you might want to pick out of, then
if you've got tons of news articles that you could display to the user.
Imagine like one set of parameters for neural network defining one model. So you really have an infinite number of them, but let's just pretend for now there are a billion. Okay? Mm-hmm. So, of course, for a given user, many of these models would make the same choice. Mm-hmm. Right? So if you randomize the news story that you present to the user, then and you look at the outcome, then suddenly you have information about all the different models that made the story you displayed, that made the same recommendation to this user, right? And you can share this user's information across all of them.
So you're effectively training a billion models in parallel.
You're effectively evaluating a billion models in parallel,
right?
And then because you're evaluating them in parallel, you can just choose the best one at the end, and voila, you have optimization, right? So it's this data sharing that's crucial, and there is a certain sense, there is a precise mathematical sense in which you can prove that this is, as a result, if you think about doing the same evaluation of a billion things through A/B testing versus what we call multi-world testing, then you require exponentially fewer samples in our approach. And there is kind of precise theory in papers backing up that claim. That's kind of the crux.
Okay. So we've touched on this throughout the discussion, but one of the big areas that you apply this on is in personalization. Mm-hmm. Can you talk a little bit about the use case and some of the background there?
Yeah. So I think really, it's 2016. I think it's great that some of the things we use actually do adapt to our tastes over time, but it's a pity that more of them don't, right? And I feel like everything I do should learn about me, especially because they are collecting a ton of data about me. So you might as well put it to some good. And basically, I think this is personalization is the one that's most interesting to me. Also, is because, like I was describing, once you start thinking. If you're just trying to evaluate 10 things, fine. There is some difference between A/B testing and multi-world testing, but it's really when you start thinking about creating personalized. And if you're only doing 10 things, then in some sense, a very smart person might just look at them and, by their gut feeling, pick out the best one, right? But once you start thinking about personalized models, then first of all, it doesn't scale for humans to do it. It doesn't scale for A/B testing to do it. You really need a different technology to do it. And that's why I think it's a very well-suited scenario to something like multi-world testing and contextual bandits. And so that's where we've found the most also excitement from, we've talked to a broad range of product managers, and that's the aspect that usually receives the most appeal to them.
And what kind of results are you seeing with that?
So I have most substantive results with MSN. We have a lot of other kind of experiments going on, but I think MSN ones are the one I can speak of most authoritatively. And basically, they've reliably. So they have like this web page with many different which they kind of logically partition into many different areas. So they've kind of applied our system to many different areas now, and reliably in all of those, they found kind of with minimal to no tuning, they found always that they were getting actually improvement in most kind of user engagement metrics that they track. What was even more interesting, and this kind of really reflects the personalization aspect, right? So they had been running these experiments in the U.S. market, and then the Olympics came around, and somebody had an idea. Hey, let's try this in Brazil, right? So this is Portuguese.
Yeah,
we've not changed anything in the system,
right,
except like the user browsing history. They had it for those users on the Portuguese articles, of course, and they did like a Portuguese topic model so just the feature extraction part was a little language specific.
Yep.
Nothing about the machine learning changed, and we got double to triple digit improvements over the existing system just deploying this out of the box, and they started running it on 100% traffic. So this it really does work.
Is that level of improvement on par with what you saw in English, or greater, or slightly less?
That's kind of difficult to judge very well, because also they have different amounts of data and different level of performance of the baseline system in different markets. Yeah, so it's it's a bit hard to compare that. Mm-hmm. But I think the important thing for them was that it was really with very little customization, things were robustly able to transfer from one market to another, right? Mm-hmm. Yeah.
And so this approach, you've talked a little bit about it being more data efficient, but how does that translate to the actual implementation and computational efficiency?
Yeah, so
is that an issue for these kinds of problems at that scale, or?
Yes, you have to be mindful about computation. We are mindful about computation. We've tried to make these things as efficient as possible. So with MSN, for instance, we were running in the front end of their servers, and we had like 5% or so performance overhead on their system, which was deemed fine for the value. So there is obviously some performance that is a loss that is incurred, but we've implemented these algorithms very carefully, and a lot of the costs can be amortized essentially. So
now the 5% running on the front end, that's for model evaluation. Is there a training step?
Yeah, but the nice thing is the training step is running asynchronously in the cloud.
Yep.
And that's entirely, currently, even at MSK, first of all, one thing that's nice about doing things online is, right, you're not really thinking about having to deal with 1 billion or 1 trillion records all at once. You're just streaming over them. So scales become nicer, so with MSN, we were still able to do all the training on one machine, in fact, in the background. But even if that's not the case, it's pretty easy to parallelize the training algorithms, and we support that. So, you can. And we've the only thing you have to be careful about is, so we've made sure that we try to keep the system very reproducible, because one of the frustrating things we've encountered over and over again is when something goes wrong in these complex systems, it's really hard to trace down what went wrong.
Right.
With parallelization, sometimes it can be a little bit more tricky, because like all of the order of events and so on. Yeah. So we recommend as far as possible to avoid it, but it's definitely possible to do it.
If you can do it for MSN on one machine, then a lot of people will be able to get pretty far on a single machine. And you've published papers about this. Like, if someone wanted to try out this approach, like, what's the best way for them to learn more about it?
Yeah, so there is a short URL, aka.ms/MWT. That website has a ton of resources on it, and it has both, more like do-it-yourself type guide type things. If you directly want to get your hands dirty, if you want to learn more about the science, it provides extensive. There's a very extensive white paper that provides links to even more extensive research papers and so on. So really, depending on how much detail you want, all of the resources are available on that website.
Awesome.
And the project itself is on GitHub, so all of the code is open source. You can play with the machine learning algorithms. The machine learning algorithms actually have been open source for several years now, so they've been tried out not just by us but by others across the research community as well.
And what are the algorithms based on? Like what general classes of algorithms do these look like?
So I mean, so the way we do things is we take these interactive or contextual bandit learning problems, and we basically sort of what the learning algorithms look like. They massage the data till you can essentially think of it as some sort of a multi-class classification problem.
Okay.
And so now go to party with your favorite multi-class classification algorithm. I mean, we implement our own for the complete pipeline, but and we support a lot of different types of models, like linear models, shallow feed-forward nets. We have matrix factorization type models. We have a whole variety of very, very quick feature manipulations that are ingrained into the models that you can just do. So all of this is happening in a software called Vopal-Vobit, all of the machine learning part, which has been around for several years and is one of the more performant software tools for machine learning out there. So it provides a lot of functionality, and if you want something that's not in it, then there are ways to plug into other machine learning libraries as well.
And your use case there was on personalization. Are there other use cases that you've seen this apply to?
So, I mean, it depends on how far you want to extend personalization, the definition, right? So one of the things we are currently trying to work on is, so we have users of Microsoft Band, and a lot of people in this country suffer from sleep disorders or just
this band is the health band.
Yes, because of like stress or other reasons, they're just not sleeping well. And so the band was for a while trying to give sleep insights, basically some recommendation to change your lifestyle in some small way that might help you sleep better. And so, for instance, we are trying to now do an experiment where we would choose which recommendations to show based on how the user's sleep then responded to the recommendations, or do this. So, I mean, I think of this as within the realm of personalization, but, and I mean, again, we haven't had conversations on a more medical domain so far, but we are really hoping that we can get there in future. So that's definitely one realm. Other definitely a good chunk of the conversations we've had other than that are, I would say, around personalization of various sorts. But even like one of the interesting use cases, some of the people in our research team are because it's a system, we also have some systems researchers on the team, and system itself does a number of resource allocation choices, and server is kind of doing load balancing, and a lot of other resource allocation problems, right? So what they've been curious is if they can apply even some of these techniques to core systems problems. We have some preliminary experiments with that, nothing I would call convincing yet, but it's actually pretty broadly applicable.
And by core systems problems, are you thinking things like, allocation of resources within a data center? And
yeah, you can apply it at several different scales. So you can think about applying it at the level of a router, at the level of a NIC, at the level of an OS, level of data center or scheduler in a data center. There are many different places you can think of it. And in some sense, a lot of these are basically currently working on top of hand-designed rules that some very smart people thought about the problem very carefully and designed it, right? But there is no reason why we can't make them more adaptive and more intelligent.
Mm-hmm.
So yeah, I think there is definitely a lot of potential there in like machine learning for systems type of area for these interactive learning situations.
And so how would you, kind of taking a step back to summarize, how would you characterize at the highest level, if you've got a problem that looks like X, this is, a solution you should
wonderful question.
look at?
I actually do, when I start to talk to people who are interested, I usually give them a template and ask them if their problem fits into that template, right? So at the high level, there is this loop of you observe the world, you take an action, and you observe a reward, right? So it's important that you face this loop over and over again. One of the things you have to be careful about, for instance, is often when we start this conversation, people don't necessarily have a well-defined notion of a reward they can point to. And that's very important. If we don't define it well, the system will just learn some garbage.
Right.
The other thing that's kind of important to think about is, like I said, contextual bandit problem, like I was saying in the talk, makes this assumption that when I take an action, it does not have influence on the next context I see, right? So something like a conversation just does not fit this. What you say is not independent of what I said before. But something like recommendation systems is largely true. So that's something you have to keep in mind when you're thinking about how good a fit this might be to your problem. Now, that said, we are, of course, we have a lot of research expertise and research advances in also working out the situations where your actions modify the state. It's just that the software not quite there yet. We have some software, but it's not really a full-fledged system yet.
Okay, great. Any other considerations or things that that folks should know when they're thinking about this space?
No, I would say again, think if you're thinking about these problems, think really hard about the reward. That's the one that usually goes wrong. And the other thing is, I think we've tried very carefully in the various materials we've prepared to outline all the usual things that go wrong, because one of the things we find is even after we talk to people, they often fall back into those traps. So it's very important to think through those carefully and make sure you don't fall into them. And
what are some of those traps?
So a lot of those traps are, essentially it's really tempting to say, right, that I have some observational data collected from my system. Let's just do some machine learning with it.
Right.
And this almost never works in a reliable manner. And there are various levels at which this manifests. So, one thing you might want to do is, I ran this experiment and actually things are working quite well now. Why don't I turn off the experimentation? I turn off the randomization. No, preferences change. Just various subtle bugs arise just due to the way people are recording things. So, of course, if you do everything with our system, then, we've designed things in a way that they shouldn't arise. But often people want to use their own custom components for parts of things. So if you're thinking about doing that, it's really important that you look into the failure modes that we emphasize and make sure you don't fall into those. And the other thing is, it just like even on top of our system, when you're building something, it's important to think about the reproducibility of everything, because that's the one thing we found really was key when even with MSN, right? It wasn't all sort of a bed of roses. Initially, there were quite a few hiccups, and because we kept everything reproducible, we could quickly figure out where the problem was.
Right. Awesome. Well, why don't you repeat that URL once more time?
It is aka.ms/MWT.
Okay, and can folks, if they've got questions, can they contact you through that URL?
Yes, absolutely.
Awesome. Well, thanks so much, Alekh. Great to meet you, and appreciate the talk.
Yeah, fun talking to you.
Thanks. All right, everyone, that's our show for today. Once again, thanks so much for listening and for your continued support. Don't forget to share your favorite quotes for a TWIML sticker. These stickers are great. You're going to love them. You can share your favorite quote via the show notes page, via Twitter, via our Facebook page, or via a comment on YouTube or SoundCloud. And don't forget to hit that iTunes link and leave us a review. The notes for this show will be up on twimlai.com/talk/17, where you'll find links to Alekh and the various resources mentioned in the show. Catch you next time.